at section 3.3, zeros of a polynomial function. This section will have higher degree polynomial equations to solve that cannot be easily factored. We will use synthetic division in our process for solving these equations. So first we have a factor theorem. A polynomial function f of x has a factor x minus k if f of k is equal to 0. So let's do some examples of this first. Determine if x minus 3 is a factor of x cubed minus x squared minus x minus 15. So that means we're looking for, turn on my pen, I'm looking for f of 3, which is 3 cubed minus 3 squared minus 3 minus 15. Well, 3 cubed is 27, minus 9 minus 3 minus 15. 29 minus 9 is 18, minus 3 is 15, equals 0, so yes, it is. Okay, determine if x plus 1 is a factor. 2x to the 10th minus x to the 9th plus x to the 8th plus x to the 7th plus 2x to the 6th minus 3. So this means we want f of negative 1. So it's 2 times negative 1 to the 10th minus negative 1 to the 9th plus negative 1 to the 8th plus negative 1 to the 7th plus 2 times negative 1 to the 6th minus 3. Well, negative 1 to the 10th is 1, so this is simply 2 times 1, or 2. Negative 1 to the 9th is negative 1, and we're taking a negative of that, so we're adding 1. Here, this becomes positive, so we're adding 1. Here, this stays negative, subtracting 1. Here, we have positive, so I have 2 times 1, so adding 2. Here, I'm subtracting 3. So I have 2 plus 1 is 3, 4, 3, 5, 2. So it is not a factor. So now we're going to look at factoring a polynomial given a 0. And we'll do this using synthetic division. Use the given 0 for synthetic division. Find the quotient using some synthetic division and factor that. So factor f of x into linear factors given that k is a 0 of f of x. Okay, so k in this case is 5. I'm looking at x minus 5 goes into 6x cubed minus 37x squared plus 32x plus 15. So x goes into 6x cubed, 6x squared times, gives me 6x cubed minus 30x squared. Again, subtracting all that, and I have minus 7x squared. Bring down my plus 32x. So now I have minus 7x, which gives me negative 7x squared plus 35x. Again, subtracting the whole thing, and it with negative 3x plus 15. So minus 3 gives me negative 3x plus 15 gives me 0. So that's one factor. X minus 5. Now, that leaves us with, we'll call it g of x for lack of better terms, 6x squared minus 7x minus 3. And this will factor to 3x minus 3, 2x plus 1. You can use your quadratic formula to help you. But if we FOIL this, just to be sure, first times first, 6x squared, outer times outer, minus 9x, inner times inner, plus 2x, last times last, minus 3, and that's minus 7x. So essentially, f of x plus 1, 2x minus 3. That is our factored polynomial. Okay, let's look at another one here. So we have 6x cubed plus 19x squared plus 2x minus 3. And we're told that negative 3 is a 0, so we have x plus 3. Again, using our synthetic division, x goes into 6x cubed, 6x squared times 6x squared times x is 6x cubed. 6x squared times 3 is plus 18x squared. Subtracting the whole thing, I have x squared plus 2x. So I multiply by x, gives me x squared plus 3x. I subtract again, I get negative x minus 3, negative 1, which is negative x minus 3, 0. So my first factor is x plus 3, and I'm left with 6x squared plus x minus 1, which is what? 3x minus 1 times 2x plus 1. And again, we can FOIL this. 6x squared plus 3x minus 2x minus 1 gives me x. Did I do that backwards? It appears that I did. We need positive x, that's right. So my factors, 3x minus 1, 2x plus 1. Now we can find the zeros, which we really found, we just didn't find. So again, the polynomial function when 0 is given, find all the others. So again, I have x cubed plus 5x squared plus 2x minus 8. And I'm saying k is equal to negative 2, so it's x plus 2. Now this is x squared, which gives me x cubed plus 2x squared. Subtracting, I have 3x squared plus 2x. So I have plus 3x gives me 3x squared plus 6x. Subtracting gives me negative 4x minus 8 minus 4, negative 4x minus 8, which is 0. So we have our first factor, x plus 2. And I'm looking at x squared plus 3x minus 4. Well, that's what? X, positive 4, negative 1. X minus 1, x plus 4. That's what our f of x equals. To find the zeros, we set all them factors equal to 0. So my zeros, we have the one given, negative 2. Here, this would give us x minus 1 equals 0. So x would equal 1. And here we have x plus 4 would equal 0. So x would equal negative 4. Okay, let's look at another one here. Again, k is 1, so we know that looking at x minus 1 goes into x cubed plus 4x squared. We don't have an x term, so we put plus 0x minus 5. So x goes into x cubed, x squared. There's this x cubed minus x squared. Subtracting all this, I get 5x squared plus 0x plus 5x gives me 5x squared minus 5x. Subtracting, I get 5x minus 5. So we do plus 5. And we get 5x minus 5. So this one doesn't look pretty. So I know I have one factor. F of x equals x minus 1. Now I'm looking at x squared plus 5x plus 5. And again, we'll call that g of x. Well, I don't see factoring that. So that brings us to the quadratic formula. X equals negative b plus or minus the square root b squared minus 4ac over 2a. So we have negative 5 plus or minus 25 minus 4 times 1 times 5 over 2 times 1, which gives me negative 5 plus or minus square root of 5 over 2. So that's two of my zeros, and x equals 1 is the third one. We can also find the polynomial function if we are given the zeros. Sometimes we might have zeros that repeat, though, and we need to know how to handle that. We might have something like this. F of x equals x plus 5 cubed times x minus 7 squared. This has a zero of negative 5 that repeats 3 times and a 0 of 7 that repeats 2 times. If f is a polynomial function and x minus c to the m is a factor of f, then c is a zero of multiplicity m. To find a polynomial of degree 3 with real coefficients that satisfies the given conditions. Has zeros of 3 and 4. So x minus 3 and x minus 4, and 4 has a multiplicity of 2. In the previous example, there was actually more than one polynomial having those zeros. What if we are given another condition? So we have zeros of negative 3, negative 2, and 5. So we have x plus 3 times x minus 2 times x minus 5. And then we're told that f of negative 1 equals 6. So if I go with this and put negative 1 in here, I have negative 1 plus 3, negative 1 minus 2, negative 1 minus 5. So this is negative 3 times negative 3 times negative 6. That's not negative 3, that's positive 2. So I have equals 36. So what can I do to this to make this 6? Well, I can simply say, we'll call it, well, I guess we're calling it f of x. X plus 3 times x minus 2 times x minus 5 divided by 6. And that will give us f of negative 1 is 6. Now we're going to go back to complex numbers. We could have a complex 0. A complex number is any number that can be written in the form a plus bi. If you recall, the square root of negative 1 is equal to I, and I squared is equal to negative 1. We've already learned how to find a polynomial if we're given the zeros, even if some of the zeros are complex numbers. Complex conjugate zeros. If a plus bi is a 0, then its complex conjugate a minus bi is also a 0. So find a polynomial of least degree with real coefficients with the zeros given. So if it has a 0 at x minus 4, or negative 4, so that's x plus 4, and x plus 3i, well, it would also have x minus 3i. That would be it. Third degree. Here we would have f of x. Okay, so it has negative 4, so that's at plus 4. It has 1 plus I, so that would be x times 1 plus I. Wait. That would be x minus 1 plus I and x plus 1 plus I, or 1 minus I. X minus 1 minus I. Not pretty. For the polynomial function, 1, 0 is given. Find all the others. So we're back to the same thing. We're given 1, x plus 1, so x minus 1 is a factor. Bring down our x cubed minus x squared plus 16x minus 16. We have x squared gives me x cubed minus x squared. Subtracting, and we get 0. I bring down my 16x minus 16. I get plus 16. And a 16x minus 16, which gives me 0. So, one of my factors of f of x is x minus 1. Now I have, and we'll call it g of x squared plus 16. Now this is not, well, we could play with this. Say x squared plus 16 equals 0. X equals negative 16, or the square root. Or x squared equals negative 16, so x equals plus or minus the square root of 16, which is plus or minus 4i. So I have x minus 4i, x plus 4i. And that would be my factors. So all the others would be 4i plus or minus. So this would be 2, and this would be the third one. Zeros wise. I forget what we're looking for here. So my zeros are 1, 4i, negative 4i. Okay, same deal here. Here k is negative 1, so I have x plus 1 as a factor. And we'll go ahead, so I don't forget zeros. We have 0. One of my zeros is 1. So x cubed minus 7x squared plus 12x plus 20. So I have x squared, which gives me x cubed plus x squared. Subtracting, I get negative 8x squared plus 12x. And minus 8x, which gives me negative 8x squared minus 8x. Subtracting, I end up with 20x plus 20. Okay, 20 here. So I get 20x plus 20. Subtracting gives me 0. So now I have x squared minus 8x plus 20. And I want to find the zeros for this. And this one looks factorable. Nope, it's not factorable. So x equals negative b, which is a negative of negative 8, plus or minus the square root, negative 8 squared minus 4 times 1 times 20 over 2 over a, which is 1. So we have 8 plus or minus square root of 64 minus 80 over 2, which is 8 plus or minus, this is negative 16, which is plus or minus 4i over 2, which is 4 plus or minus 2i. So 4 plus 2i, 4 minus 2i. Those are my zeros. Okay. Been a while since I've solved these this way. If I told you how long, you wouldn't believe me. Try over 40 years. So that's it for this recording. Have a good day, and we will see you next time.